Okay, in this presentation we are going to look at a quick statistical analysis of a hypothetical situation. Now this is an introduction to R for actuarial students and it corresponds to the CS1B curriculum, and that comprises introduction to R programming and fundamentals of statistical analysis. So this is beginners level R stuff and beginners level statistics with R level stuff, and this will correspond to a question 1 type question that will come up in the papers. So the question is, in a small country, a political election was held recently to decide on a political party to govern the country. A survey was carried out to monitor the approval rating for the winning political party. A sample of 15 voters were asked to complete the survey twice, once just before the election, approval before, okay, and a second time 6 months after to, again, 6 months after the election, approval after. So it's a before and after situation. The survey asked each of the 15 voters to record their approval for the winning political party on a scale of 1 to 10, where 1 was strongly disapprove and 10 was strongly approve. The results are shown in the following table here. So we have our 15 voters, okay, and this is the score that they gave before the election, and this is the score that they gave after the election. Now we can enter these values into R using the following bits of code. So just the two little lines of code there: approval before, we set up that little vector, and approval after with that vector there as well. Straightforward data entry operation with R. So there's 4 questions. Calculate the means of the approval before and the approval after results. Outline why Kendall's tau would be a suitable correlation coefficient to use for these results. Calculate Kendall's tau coefficient between the approval before and after results, and just comment on your answers in exercise 1 and 3. So exercise 1, the sample estimates. Enter the data into R using the commands provided in the question. So this is the code we are given: approval before, approval after. This command C is used to create or concatenate all of these values into a single vector, a single object, okay? So we get the mean using mean. Just state the name of the vector that we want the mean of. 7.2 for approval before, 4.266 for approval afterwards, okay? So that's the first question, the first exercise. Exercise 2 and 3 we're going to do together. Kendall's rank correlation coefficient will measure the strength of a monotonic relationship between approval before and approval after results. Okay, it considers only the relative values of the bivariate data and not their actual values. It does not assume linearity between the bivariate data. So this is the command core or correlation. Okay, name the 2 vectors, approval before and approval after. And there we just specify that it should be the Kendall's correlation coefficient, and that's the score Kendall's correlation coefficient that we would get, the Kendall's tau 0.1819, and so on. Just as a quick remark, we do not use the Pearson correlation coefficient because this is ordinal data. It's essentially ranking between 1 and 10, so it's a ranking rather than a continuous variable that is not bounded or it's just a real number. This is a ranking, so it's actually is a sort of level on a scale, an ordinal scale. So in that case, that would not be appropriate use of the Pearson correlation coefficient. So that's where the Kendall would come in. We could also use the Spearman correlation coefficient as well as an alternative to the Kendall's tau. Essentially, what we do there is state method equals Spearman. Okay, and we get a result that should be fairly similar, 0.247. Okay, now if we do want to check the Pearson correlation coefficient, just because we want to know, essentially all we have to do is write core and name the 2 vectors that we want. The result would be 0.342 and so on. Now, if we wanted to be extra clear, we could actually write method equals Pearson down here. Okay, just after that, the default is actually Pearson. So we want this Kendall correlation coefficient or the Spearman correlation coefficient. What we have to do is make this additional specification. So that's exercise 3. So what's your conclusion? From exercise 1, the mean approval has fallen from 7.2 to 4.3, 4.266. Kendall's tau in exercise 3 shows that there's a weak correlation between the approval scores before and after. And from the overall analysis from exercises 1 and 3, this suggests that generally the 15 voters' approval has changed and the approval has fallen. So, or the shift in opinion has not been the same across the survey. Okay. Has not been the same across those surveyed. Okay. That's based on the correlation coefficient. So some people have different opinions before and after. So that's it. Yeah, we'll leave it there.